3.8 Finding real roots of polynomial equations. When we are doing these equations and we are solving, we're just solving for x, so we want to get everything on the same side, so our equation's equal to 0. We want to factor out whatever we have on that one side. So remember, our rules for factoring: if you can factor out the greatest common factor, do that first, then factor according to what you have. From there, we are going to factor, then set each part equal to 0 and solve for x for each part. If we look at example 1a, we have x minus 5 times x plus 2 is equal to 0. So we're going to set each part of that equal to 0. So the x minus 5 gets set equal to 0, as well as the x plus 2 gets set equal to 0. We can get rid of those parentheses, so that way we just have the x minus 5 and the x plus 2. And then we solve for x for each. So with the x minus 5 is equal to 0, we're going to add the 5 to both sides, and we get that x is equal to 5. For the x plus 2 is equal to 0, we're going to subtract 2 from each side, and x is equal to negative 2. So x is equal to negative 2 as well as 5. You can also write this as the solution set of negative 2, 5. If we look at b, we have x squared is equal to x plus 30. So our whole idea is to get it equal to 0 first. So we're going to subtract that x from both sides. We get x squared minus x is equal to 30. Then we're going to subtract the 30 from each side and be left with x squared minus x minus 30 is equal to 0. So now find the factors of 30, of negative 30, that equal the negative 1. Well, we have negative 1, we have 30, we have negative 2, 15, negative 3, 10, negative 5, 6. Well, negative 5 and 6, if the 5 was positive and the 6 was negative, that would give us the negative 1 that we're looking for. So we're going to have x plus 5 times x minus 6 is equal to 0. So now set each part equal to 0. So x plus 5 is equal to 0, and x minus 6 is equal to 0. Solve for x for both. For the x plus 5 is equal to 0, we're going to subtract 5 from each side. So x is equal to negative 5. And the x minus 6 is equal to 0. We're going to add 6 to both sides to get that x is equal to 6. So this is the solution set of negative 5 and 6. If we look at our next example, C, we have 3x to the 5th power plus 18x to the 4th power plus 27x cubed is equal to 0. So first factor out your greatest common factor, which is the 3x cubed. So if we factor out the 3x cubed, we're going to have 3x cubed times what's left over. We're going to have x squared plus 6x plus 9 is equal to 0. So from here, we're going to factor the x squared plus 6x plus 9. The factors of the 9 that equal the 6 are 3 and 3. So we're going to have 3x cubed times x plus 3 times x plus 3 is equal to 0. So from here, we're going to set each part equal to 0. So 3x cubed is equal to 0, and x plus 3 is equal to 0. Because we have that x plus 3 twice, when we do it twice, we're going to get the same answer for x. So we don't have to do it twice, we can just do it once. For the 3x cubed is equal to 0, divide by 3 on both sides. We get x cubed is equal to 0. And then take the cube root of both sides. The cube root of 0 is 0. So x is equal to 0 for one, and the other one we're going to subtract that 3 from both sides and get that x is equal to negative 3. So we have a solution set of negative 3 and 0. For D, we have x to the 4th power minus 13x squared is equal to negative 36. So move that 36 over by adding it to both sides. We're going to have x to the 4th power minus 13x squared is equal, plus 36 is equal to 0. From here, we're going to factor this. The factors of 36 that equal a negative 13 is a negative 4 and a negative 9. So you got to be able to pay attention. This x to the fourth is going to split up as x squared minus 4, as well as x squared minus 9 is equal to 0. Well, we can still factor this x squared minus 4 as well as this x squared minus 9. So this x squared minus 4 is the difference of squares, so it's going to be x minus 2, x plus 2. This x squared minus 9 is the difference of squares with x minus 3 and x plus 3. So now set each part equal to 0. So we're going to have x minus 2 is equal to 0, x plus 2 is equal to 0, x minus 3 is equal to 0, as well as x plus 3 is equal to 0. So we're going to solve for x for all four of these. For the x minus 2 is equal to 0, add 2 to both sides, x is positive 2. With the x plus 2 is equal to 0, subtract 2 from both sides, and we get that x is equal to negative 2. With the x minus 3 is equal to 0, add the 3 to both sides, we get x is equal to positive 3, and the x plus 3 is equal to 0, subtract 3 from both sides, we get x is equal to negative 3. So our solution set for all of these is negative 3, negative 2, positive 2, positive 3. So all four of those are our answers. If we look at our next example, we have 2x to the 6th power minus 10x to the 5th power minus 12x to the 4th power is equal to 0. So we're going to factor out our greatest common factor with these, which is going to be a 2x to the 4th power. So it's going to come out front. We're going to be left with x squared minus 5x minus 6 is equal to 0. From here, factor the x squared minus 5x minus 6. Your factors of negative 6 that add up to be a negative 5 are a positive 1 and a negative 6. So this is going to become 2x to the 4th power times x plus 1 times x minus 6 is equal to 0. So again, set each part equal to 0. We're going to have 2x to the 4th is equal to 0, x plus 1 is equal to 0, and x minus 6 is equal to 0. For the 2x to the 4th power is equal to 0. Divide each side by 2. We're going to have x to the 4th power is equal to 0. If we take the square root of, the 4th root of both sides, we're going to have that x is equal to 0. For the x plus 1 is equal to 0, subtract 1 from both sides, so x is equal to negative 1. And with the x minus 6 is equal to 0, add 6 to both sides, we get that x is equal to positive 6. So our solution set for this is negative 1, 0, and 6. For f, we have x cubed minus 2x squared minus 25 is equal to negative 50. So move the 50 over. Remember, we wanted this equal to 0. So we're going to add the 50 to both sides. We're going to have x cubed minus 2x squared minus 25x plus 50 is equal to 0. We have four terms, so factor by grouping. For the first set, we're going to factor out an x squared. For the second, we're going to factor out a negative 25. So we're going to simplify this. We're going to have x squared times x minus 2, as well as negative 25 times x minus 2 is equal to 0. So this is going to simplify even further as x squared minus 25 times x minus 2 is equal to 0. That x squared minus 25 is the difference of squares, so simplify that further as x minus 5 times x plus 5. Then you have that x minus 2 as well. So you have to set all three parts equal to 0 now. So x minus 5 is equal to 0, x plus 5 is equal to 0, and x minus 2 is equal to 0. Simplify these all, add the 5 to both sides, and the x minus 5 is equal to 0. You get that x is equal to 5. Subtract the 5 to both sides, and the x plus 5 is equal to 0. You get x is equal to negative 5. And then add the 2 to both sides, and the x minus 2 is equal to 0. You get x is equal to positive 2. So your solution set for this one is going to be negative 5, 2, positive 5. If we look at G, we have 3x cubed is equal to 4x times 2x minus 1. So with this one's a little bit more difficult. You have a little bit more steps. So you're going to first start by distributing in the 4x. We're going to get 3x cubed is equal to 8x squared minus 4x. From here, move all of your terms over to be on the same side as that 3x cubed. So we're going to subtract 8x squared to both sides and be left with 3x cubed minus 8x squared is equal to negative 4x. Then we're going to move the 4x over by adding it to both sides. So we have 3x cubed minus 8x squared plus 4x is equal to 0. Do we have a common factor between all three of these terms? Yes, an x. So we're going to factor out an x. This is going to leave us with x times 3x squared minus 8x plus 4 is equal to 0. So now you have an a that's not 1. So multiply the a and the c, so the 3 and the 4 multiply to be 12. The factors of 12 that add up to be the negative 8. We're going to have 1 and 12, 2 and 6. There we go. A negative 2 and a negative 6 is going to give us a negative 8. So we're going to replace that negative 8x with the negative 2x and the negative 6x. So we're going to have x times 3x squared minus 2x minus 6x plus 4 is equal to 0. So from here, factor by grouping. We're going to factor out an x from the first set. We're going to factor out a negative 2 from the second set. So this is going to leave us with x times 3x minus 2 and a negative 2 times 3x minus 2 is equal to 0. So from here, go ahead and rewrite this to where you have x times x minus 2 times 3x minus 2 is equal to 0. Set each part equal to 0 now. You have x is equal to 0, x minus 2 is equal to 0, and 3x minus 2 is equal to 0. The x is equal to 0, that's a solution. With the x minus 2 is equal to 0, add 2 to both sides, you get that x is equal to 2. With the 3x minus 2 is equal to 0, add the 2 to both sides, and then you're going to divide each side by 3. So then we have that x is equal to 2/3. So your solution set here is x is equal to 0, 2/3, and 2. So like I said, that one was a little bit longer. Not any different than any of the other ones, but a little bit longer. All right, so if we look at our next part of this lesson, we're dealing with multiplicity. Multiplicity is identifying those answers that are represented more than once. So you have certain answers that appear more than once, and that's when you have your multiplicity. So if we look at example 2a, we have x plus 3 times x minus 2 times x plus 3 is equal to 0. So we're going to start by rewriting all of this by having it equal to 0. So x plus 3 is equal to 0, x minus 2 is equal to 0, and x plus 3 is equal to 0. We're going to add the 3 to both sides to get that x is equal to 3. We're going to add the 2 to both sides. Oops, this was supposed to be subtraction. Let's go back. This is supposed to be subtracting, so it's not a positive 3. Subtract 3 from both sides. We get x is equal to negative 3. There we go. If we added the 2 to both sides, we get x is equal to 2. And then if we subtract the 3 from both sides on this one, we get x is equal to negative 3. So our solution set for this is that we have negative 3 and 2 as our solutions, but we have a multiplicity 2 times at x is equal to negative 3 because the x is equal to negative 3 is an answer twice. So we have a multiplicity 2 times at x is equal to negative 3. So all of this is your answer, especially when it tells you to state the multiplicity. You have to make sure you write multiplicity, how many times at x is equal to where. If we look at B, we have y plus 4 raised to the third power times y minus 2 raised to the second power times y plus 1 is equal to 0. So this is the same thing as saying y plus 4 times y plus 4 times y plus 4 times y minus 2 times y minus 2 times y plus 1 is equal to 0. So if we were to set all of these equal to 0 and solve, we would have a multiplicity of 3 at y is equal to what for the y plus 4 is equal to, or y plus 4 cubed. So again, we're going to have to keep that in mind while we're doing this. So I'm going to solve one of these for all three. So the y plus 4 gets that equal to 0. I'm going to subtract 4 from each side, and we have that y is equal to negative 4. For the y minus 2, I have 2 of those, so I'm going to do y minus 2 is equal to 0. I'm going to add the 2 to both sides and get y is equal to 2. And then for the y plus 1, we have y plus 1 is equal to 0. We're going to subtract 1 from both sides and get that y is equal to negative 1. So look at all of the negative 4s that we have. We have 3 of those, so there's a multiplicity of 3 at y is equal to, at y is equal to negative 4. Then we have a multiplicity of 2 at y is equal to 2. And then we have a multiplicity of 1 at y is equal to negative 1. If we look at our next example, C, we have x minus 1 raised to the 5th power times x plus 6 raised to the 2nd power times x minus 10 raised to the 3rd power is equal to 0. So we're going to solve all of these, except for this one, we're only going to do it once. X minus 1 is equal to 0. X, we're going to add the 1. X is equal to 1. For the x plus 6 is equal to 0, we're going to subtract the 6 from both sides. So x is equal to negative 6. And with the x minus 10 is equal to 0, we're going to add the 10 to both sides to get x is equal to 10. So when you write this, we have a multiplicity of 5 at x is equal to 1. We have a multiplicity of 2 at x is equal to negative 6. And then we have a multiplicity of 3 at x is equal to 10. For our next example, D, we have x minus 7 times x plus 3 times x plus 7 times x plus 3 times x minus 7 times x plus 5 is equal to 0. So we could rewrite this. How many x minus 7s do you have? You have 2. Oops. So that's going to be raised to the 2nd power. How many x plus 3s do you have? 2. So that's going to be raised to the 2nd power. And then you have the x plus 7 and the x plus 5. So we can go ahead and solve 4 of these instead of solving as many as we see at first. So we're going to set the x minus 7 equal to 0, the x plus 3 equal to 0, the x plus 7 equal to 0, and the x plus 5 equal to 0. For the x minus 7 is equal to 0, add the 7 to both sides. We get that x is equal to 7. For the x plus 3 is equal to 0, subtract that 3 from both sides, we get x is equal to negative 3. For the x plus 7 is equal to 0, subtract the 7 from both sides. We get x is equal to negative 7. And the x plus 5 is equal to 0, subtract the 5 from both sides. We get x is equal to negative 5. So look at your multiplicities here. We have 2 at 7. We have 2 at negative 3, and then a 1 and a 1 at the negative 7 and the negative 5. So write this out with your multiplicity. We have a multiplicity of 2 at x is equal to 7 and x is equal to negative 3. Oops. Then we also have a multiplicity of 1 at x is equal to negative 7 and x is equal to negative 5. For e, we have x cubed minus 9x plus 27x minus 27 is equal to 0. So we're going to factor by grouping here. First 2, last 2. We're going to factor out an x squared from the first. We're going to factor out a 27 from the second. So this is going to be x squared times x minus 9. And then we're going to have a 27 times x minus 1. So these are not the same. So because they're not the same, you can't factor by grouping. So you got to find the factors of the constants and divide by the positive and the negative factors. So we're going to use synthetic division by doing this. So I'm going to erase all of this. So we're going to go back. Nope. I'm going to erase this. I can't erase that. Oh, yes, I can. There we go. Okay. So we're going to start over by using synthetic division. So your factors of the negative 27. We have 1 and negative 27, 3 and negative 9. We have a negative 1 and a positive 27, and also a negative 3 and a positive 9. So try the 1, see if the 1 works. So we're going to start with the 1. It's going to go on the outside. We're going to have a 1, a negative 9, a 27, and a negative 27. Use synthetic division. Bring down the first. 1 times 1 is 1. Add it with the negative 9. You get negative 8. Negative 8 times 1 is negative 8. Add it with the 27. We get 19. 19 times 1 is 19. And 19 minus 27 is negative 8. That's not a 0, so that does not work. So try the positive 3. If we try the 3, we still have the 1, the negative 9, the 27, and the negative 27. So the 1 drops down. 1 times 3 is 3. Negative 9 plus 3 gives us negative 6. Negative 6 times 3 gives us negative 18. The 27 minus 18 is 9. 9 times 3 is 27, and negative 27 plus 27 is 0. Because we have a remainder of 0 there, that 3 works. So x is equal to 3. X is equal to 3. From here, we're going to have what we got as our solution from the synthetic division, the 1, the negative 6, and the 9. The 0 was our remainder, the 9 is our constant, the 6 is our x, the 1 is our x squared. So this is going to give us x squared minus 6x plus 9 is equal to 0. Factor that. The factors of 9 that add up to be a negative 6 are a negative 3 and a negative 3. So we're going to set both of those equal to 0. So x minus 3 is equal to 0, and x minus 3 is equal to 0. These are both the same, so we're going to solve for 1. And I get that x is equal to positive 3. So I have this twice, and then I have it another time up here. So we have a multiplicity of 3. At x is equal to 3. So again, if you can't factor by grouping, find the factors of that constant, and then use synthetic division to see which one works and gives you a remainder of 0. Once we find that one, then go ahead and rewrite your expression and factor your trinomial. If we look at example F, we have negative 2x cubed minus 12x squared plus 30x plus 200 is equal to 0. We have a common factor here of negative 2, so we're going to factor out the negative 2 and be left with x cubed plus 6x squared plus 15x, negative. So this 15 is going to be negative x, there we go, and then negative 200 is equal to 0. So from here, the negative 2 is going to stay out front. First, find your factors of the 100. It's supposed to be 100, not 200. There we go. All right, so first find the factors of 100. We're going to find the positive ones first. We have 1 and 100, 2 and 50. We have 4 and 25. We have 5 and 20, as well as 10 and 10. I'm going to try the 4, just because I know that's going to work. So 4 is what we're going to use. Our terms that we're going to have there is going to be a 1, a 6, a negative 15, and a negative 100. So the 1 drops down. 1 times 4 is 4. 4 plus 6 is 10. 10 times 4 is 40. Minus 15 is, minus 15 is 25. And 25 times 4 is 100. If we add that to the negative 100, we get a 0 as our remainder. So we're going to take that x is equal to 4. That's one of our solutions. Then we're going to have this is our remainder, our constant, our x squared. So this is giving us x squared plus 10x plus 25 is equal to 0. The factors of 25 that add up to be a 10 are x plus 5 as well as x plus 5 is equal to 0. So the x plus 5 and the x plus 5, we're going to set both of those equal to 0. We can solve one of them by adding the 5 to both sides and get that x, subtract 5 from both sides. There we go. And x is equal to negative 5. We have that twice, and then we also have that x is equal to negative 4. So we're going to write this, that x is equal to negative 4. We have a multiplicity of 1. At x is equal to x is equal to 4, and then a multiplicity of 2 at x is equal to negative 5. If we look at our next set of examples, for g, we have x to the 4th power minus 18x cubed plus 24x squared minus 32x plus 16 is equal to 0. So we're going to find the factors of 16. The factors of 16 are 1 and 16, 2 and 8, 4 and 4. I know because I've done this already that 2 works. So I'm going to take the 2, put it in my box. I'm going to use 1, negative 8, 24, negative 32, and 16, and use my synthetic division. So I'm going to bring the 1 down. 1 times 2 is 2. Add that with a negative 8, we get a negative 6. Negative 6 times 2 is negative 12. Add that with the 24, we get 12. 12 times 2 is 24. Add that with the negative 32, we're left at negative 8. Negative 8 times 2 is negative 16. 16 minus 16 is 0. So this one works. X is equal to 2 is one of our solutions. So remember, we have to rewrite this. This negative 8's our constant. We have 12x, negative 6x squared, and x cubed. So x cubed minus 6x squared plus 12x minus 8 is equal to 0. So again, we can't factor this by grouping. We're not going to get the same parentheses. So find the factors of that negative 8 that we can go ahead and use our synthetic division for. So we're going to have negative 8 is negative 1 and 8. We also have negative 2 and 4, positive 1 and negative 8, and positive 2 and negative 4. Again, I know that the 2 works because I've done this before, so I'm going to use the 2 in my synthetic division. I'm going to have 1, negative 6, 12, and negative 8. I'm going to bring down the 1. 1 times 2 is 2. 2 minus 6 is negative 4. Negative 4 times 2 is negative 8. 12 minus 8 is 4. 4 times 2 is 8. Negative 8 plus 8 is 0. So this one works as well. The x is equal to 2 is another solution. So from here, I have the 4, that's my constant, the negative 4, that's my x, and my 1, that's my x squared. So I'm going to rewrite this as x squared minus 4x plus 4 is equal to 0. I can factor this. The factors of 4 that give me a negative 4 when added together are a negative 2 and a negative 2. So I'm going to simplify this by doing x minus 2 is equal to 0, as well as x minus 2 is equal to 0. I'm going to solve for this to add 2 to both sides and get that x is equal to 2. So this one's also going to be x is equal to 2. So how many of these do I have? 1, 2, 3, 4. So we have a multiplicity of 4 at x is equal to 2. Multiplicity of 4 at x is equal to 2. For h, we have 2x to the 6th power minus 22x to the 5th power plus 48x to the 4th power plus 72x cubed is equal to 0. So I'm going to factor out my greatest common factor here, which is 2x cubed. This is going to leave me with 2x cubed times x cubed minus 11x squared plus 24x plus 36 is equal to 0. I can already start by doing 2x cubed is equal to 0. Divide the 2 from each side to get x cubed is equal to 0. Then take the cube root of both sides and get that x is equal to 0. So that's one of my solutions. The x cubed minus 11x squared plus 24x plus 36 is equal to 0. My factors of 36, find those. 36 is 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So I want to find the ones that add up, or sorry, if I want to use my synthetic division with all of these. I know that the 6 is going to work, so the 6 is what I'm going to put on the outside. Then I'm going to have a 1, a negative 11, a 24, a 36. I'm going to bring the 1 down, multiply it with the 6 to get 6, add it with the negative 11, I get negative 5. Negative 5 times 6 is negative 30. Add that with the 24, I'm left with negative 6. Negative 6 times 6 is negative 36. I get 0. That works. So the 6 is the negative 6 is my constant. Then I have the 5, that's my x, and my 1, that's my x squared. So the x is equal to 6 is a solution as well. We're going to keep that with the 0. We're going to rewrite this as x squared minus 5x minus 6 is equal to 0. Then we're going to factor this out. The factors of negative 6 that add up to be a negative 5 are going to be negative 6 and positive 1. So this is x plus 1 times x minus 6 is equal to 0. Set both of them equal to 0 and solve. So x plus 1 is equal to 0, x minus 6 is equal to 0. We're going to we're going to subtract the 1 from both sides and get that x is equal to negative 1. Then we're going to add the 6 to both sides for the other and get that x is equal to 6. So look at our solutions now. We have x is equal to 0, x is equal to 6, x is equal to negative 1, and x is equal to 6. So use your multiplicity here. We have a multiplicity of what and what? We have a multiplicity of 1 at x is equal to 0 and x is equal to negative 1. Then we also have a multiplicity of 2 at x is equal to 6.